Welcome to Tetryonics. In this lecture we'll be covering the geometric foundation of mathematics and physics. This is an introductory lecture leading into special relativity and general relativity. Specifically, it's covering how equilateral mass energies form three-dimensional matter and the mathematics of physics itself. This lecture is based on material contained in Tetryonic Book 5, Geometrics, and it's available on YouTube and Google+, as well as Pirate Bay. Equilateral geometry forms the cornerstone of all two-dimensional mass energies, and it's this geometry that leads us to the mathematics of physics as it's currently formulated. Tetryonics shows how this geometry is in fact the foundation for all the mathematics within physics and within the field of mathematics in general. Obviously, the formulation of mathematics stems back in history to the Greeks and how they applied a language or a set of rules, mathematical symbols, to their description of their various geometries. Euclid's probably the most famous of all the mathematicians of Greek times. He developed 13 books called the Elements, which we'll discuss later. But in general, they're a formal language. Well, mathematics is the formal language used to describe the geometries. Recently, mathematics has developed into a field of its own, where by using the given rules of mathematics and the logic of mathematics, extrapolations have taken place to try and define physics. Tetryonics now reverses that process and uses the geometry that forms the foundation of the mathematics to give us set rules or physical interactions. Mathematics is often described as being the language of physics, and if that is indeed the case, then geometry, its foundation, is best described as the grammar. It sets the stage and the rules for the interactions that are possible. And throughout Tetryonics, there are a number of examples where extrapolations based on the rules of mathematics have resulted in erroneous statements or hypotheses regarding physical mechanics. Tetryonics, being a geometry-based theory of physics, does not have this problem, and in fact it corrects the erroneous assumptions of mathematics through its rigid and fixed geometry of mass energy and matter. Looking back at the Greeks, they invented a geometry called Tetractys, I think it's pronounced, in which you'll note the numbering system for it represented the decimal system or base 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this formed the basis of what's commonly called these days sacred numbering. They applied this also to their attempt to understand the universe in terms of geometry and Platonic Solids, and within the four elements known, along with the symmetry between the sun and the moon, the stars and the planets, male, female, and the four elements themselves. Tetryonics builds on this by showing that, in fact, the numbering system, while represented as a base 10 in the Greek system, is in fact a square number system, where, as we've discussed, odd-numbered energy bosons combine sequentially or sum together or integrate to form a scalar square number. In the case of Tetryonics, we now reorganize the numbering system from a base 10 to a square base system based on the geometry of equilateral triangles. These triangles obviously represent the energy of a energy quanta of a system, measured system, or its mass content where it's measured per unit of time. And it's the geometries that these equilateral energy quanta can form through their charge interactions that results in everything within our physical universe, both in terms of force, constants, two-dimensional energy, mass, and three-dimensional matter. In rearranging the sacred number geometry of the Greeks, we can now show that a single triangle, i.e. a quanta or a quantum of 1, in fact represents a 0-point energy field. This energy field can obviously have a electric and a magnetic component within its scalar energies, and a measurement of its linear momentum forms the basis of a line in geometry, or a tensor zero tensor. The second row within the triangle, consisting in this case of 3 mass energies, can in fact represent quantum levels within physical systems. Obviously, as odd-numbered bosons come together, or quantum levels integrate, we obtain square-numbered energy levels within the scalar field. The odd-numbered bosons, or the quantum levels within physics, are in fact bosons. They can be a positive or a negative charge depending on their constituent odd-numbered quanta. The even-numbered quanta of positive and negative charges forms the basis of photons. Again, as we've discussed in previous lectures, bosons are a transverse measurement of the field with respect to the linear momentum of the field, and photons are a longitudinal or linear measurement of the energy momenta with respect to the linear momentum of the energy field. Highlighting the number of geometries that can be developed from equilateral energy quanta gives us the basis of many different numbering systems within Tetryonics. Obviously, we have the familiar photons, or tau pi geometries, 2 pi geometries, where we have positive and negatives coming together to form a neutral energy quanta. We can also develop fractal systems within energy fields, where we measure specific frequencies and frequency arrangements within the energy fields themselves. Obviously, these are drawn with a number of different energy geometries within this one schema, but these distinct fractals and icons and photons can all be applied throughout each squared energy field. And of course, we have a number of religious icons and mystical symbols that also arise from equilateral geometries. As I've just mentioned, you'll note that within all equilateral or square energy fields within Tetryonics, we have 3 letters on the outside of the fields, and these letters have a specific meaning with respect to the quantization of energy within that field. At the left-hand side, we have nu, which represents Planck nu, or odd-numbered bosons, odd-numbered geometries within the squared geometries. They form the quantum levels. So where you see h nu, you can take it as read that it's an odd number, particularly where you have a golden color or a red or black for positive or negative charges. Again, it's these odd numbers in a sequence, as you see highlighted here within the summing on the right hand side of the page, that gives us the square energy levels of physics. These geometries can be any geometry. In this case, they're representative of an equilateral scalar field. However, they can form fractals, they can form photons, they can in fact form three-dimensional matter with square energies within their charged fascia. Again, the basis of all mass, energy, matter within the universe is equilateral or square geometries, with the quantum of mass energy being a single equilateral triangle of 1 or 1 squared. Again, this is unique in the fact that this quantum can also be representative of charged bosons, i.e. it's an odd number as well as being a square number. So depending on whether you're measuring the energy content, the charge, or the energy content per second, per unit of time, i.e. mass, you can have different physical properties, including energy and momenta if you take the square root of the system. And of course there's two forms of momenta within the equilateral geometries. There's the linear momenta formed by its square root, as indicated with the pink or fuchsia arrow, and then there's also the geometry itself, the equilateral geometry, which is the angular momentum, square meters per second. For those of you that aren't familiar with the equilateral geometries being square geometries, the very first lecture in this series delves into the equilateral geometry of energy itself, along with mass, matter. And of course this quantized angular momentum, the equilateral geometry, can be represented electrically as a vector rotation in the clockwise or anti-clockwise direction for positive or negative charges within quantum mechanics. Applying this to some of the basic formulations for math, we can see that in the case of Pythagorean theorem, where the sum of the sides equals the square of the hypotenuse, we can in fact, which have been drawn with square geometries, i.e. the first two sides squared equals the third side squared, or the hypotenuse. We can in fact redraw this using equilateral square geometries to give us a different interpretation and a completely different geometry that still follows the mathematical formulation. This is one of the foundational and first examples where geometry forms the basis for mathematics. In fact, both geometries are correct. However, it's more appropriate to say that square geometries are equilateral geometries, where obviously a square has equal length sides and equal angles within it, i.e. 90 degrees. And equilateral geometries have equal length sides and identical angles within them, in this case 60 degrees. The difference obviously being the sum of the angles within them. In the case of a square it adds up to 360, in the case of a triangle it adds up to 180. So we can in fact redraw or re-explain the foundations for mathematics, and from this geometric change in perspective as to what constitutes the foundation for mathematics, we can in fact develop a completely new understanding of physics, as we have done in the previous lectures. This becomes extremely important when you look at things like energy and motion, the energy of those fields that are created from matter in motion, and particularly how we relate this back to specific things like electrodynamics and relativity itself. Obviously, with equilateral geometries being square geometries, as we add consecutive numbers of equilateral triangles together, we continue to form square numbered geometries that only differ from each other in how many pi radian geometries they contain. This can be any number, and in fact, as we add up sequential odd numbered square energy geometries, we form larger and larger scalar fields of square numbered or square quanta energies. These can all obviously go on to form faceted charged geometries of matter, and in the case of atomic nuclei, they can then combine, as illustrated here at the bottom left, in regular patterns to give us s and p orbitals along with d and f orbitals of atomic nuclei, again explained in more detail in the chemistry lectures. Of course, this packing can take place in a number of different arrangements. However, the hexagonal tessellation that's shown on the bottom right here is unlikely to occur within chemistry, as shown on the left, due to the fact that there will be bound electrons within these elements in most cases, and these electrons prevent the atomic nuclei coming together completely. In addition, the equilateral geometry of the three quarks that make up the baryons creates a unique geometry where we have a differing number of fascia at the top and bottom of each element. Again, looking closely at the equilateral geometry lecture and making the models for yourself, you will see that it is a very unique geometry, and this prevents atomic nuclei from packing really close to each other in the formulation or in the geometry shown at the bottom right. It does appear in larger scale matter, but it doesn't appear at the quantum level of atomic nuclei. Again, the important thing to note here is that each equilateral triangle has a square number of mass energy quanta within each geometry, and it's the multiplication of the square energy levels by the charged equilateral geometries that make up large-scale matter that gives us the mass of each matter geometry or each particle. Obviously, with charged fascia, equilateral charged fascia, they can form any number of geometries, and the most common are known are the Platonic solids. These tend to exclude spheres and circles, or spheres in particular, because they don't have edges and vertexes to follow the general rule for Platonic solids, where the number of faces minus the edges plus the vertexes in each geometry always adds up to 2. Again, the most important one, known to the Greeks as the geometry for fire, is the tetrahedral geometry. This is the geometry, the first three-dimensional geometry that forms using equilateral energies, mass energies, and this is known in Tetryonics as the tetryon. It is the quantum of matter. It's the first geometry to be three-dimensional as a Platonic solid, and its fascia are all square mass energies, forming three-dimensional matter geometries, with matter being a mass energy geometry that takes up a volume, whereas mass energy itself is a flat Euclidean or planar EM wave. Of course, this can expand in ever-increasing geometries until you encounter things like icosahedrons, which you'll see explained within Tetryonics as being a marvelous geometry that gives us a completely neutral particle with polarized positive and negative ends within its geometry. And if you draw planes between its vertexes, you'll form 3 planes that represent three-dimensional matter. So it's a very nice way of illustrating 3D space-time, as in the region of a spatial coordinate system in which matter is in one form or another, be it mass or energy is in one form or another, be it mass or matter, and the charge, i.e. the time, is given by the equilateral geometry of the mass energy itself. So we have a measurement of space, time, and the mass energy within it. Euclid, as I mentioned, is probably the most famous for having developed 13 books called the Elements on geometry. Unfortunately, like most mathematicians, there's very little in his books about equilateral geometries themselves, and in particular the fact that they represent square numbers. This seems to be something that's been overlooked within geometry and mathematics for a large length of time to date. There are mentions of it in various places. However, the most common formulations you'll see for the square geometries made up from equilateral geometries is things like Sierpinski's gasket and other things like that, and more likely they will count them in terms of the Greek sacred geometry, i.e. base 10, than they will in pointing out that they are square numbers if you count the geometries themselves rather than the points that they form within the equilateral geometry. Tetryonics now corrects a lot of these mistakes and things that have been overlooked in time, and that forms the basis of the 5 books of Tetryonics. Again, it's an extension of the Euclidean geometry in terms of mass energy, and it then extends into 3-dimensional matter geometries where the mass energy interacts via its charged arrangements. Archimedes was the first to do an approximation of pi as it's known within current mathematics of physics. And I won't go into it here other than to quickly explain that what he did was draw a circle and then draw the radius. Using that radius he drew a second circle, in which case both circles had a radius of the same length, and then where that circles intersected he drew a line. This then gave us a equilateral geometry within the 2 circles, which could then be duplicated for any one of the 2 circles. In doing this, he showed that 6 triangles, or 6 equilateral triangles, can fit within the circle, but there is space left over, and this is because a straight line is the shortest path, whereas the circle takes a longer path to complete its geometry. So he knew from a general rule that pi is expressed as a ratio between the circumference of a circle and its diameter, 2 radii, would be slightly larger than 6. As a diameter it's slightly larger than 3. As a relationship between the circumference and the radius, it will be slightly more than 6, as shown in this illustration here. And in fact, that's the preferential way of describing pi within Tetryonics. It's not to describe it as pi, but as a tau geometry, where tau is the relationship of the circle to its radius, and pi still remains a relationship of the circle to its diameter. The difference being obviously that 2 pi equals a tau. In the case of Tetryonics, we refer to the pi geometries in terms of their radians, obviously, so that each equilateral charged fascia can be designated a pi geometry or part of the overall pi geometries. And in fact, this allows us to calculate the mass energies and determine the geometries for all matter. There are a number of other fascinating features in the mathematics and the geometry of equilateral triangles, things like the golden ratio. I'll let you view this illustration and its detail on your own, but just to summarize, the relationship between L to M versus XL or MY is in the order of the golden ratio. Well, in fact, it is the golden ratio. The interesting part about this situation here is where you have the golden ratio formed by these two lines, internal and external to the equilateral triangle, or the scalar mass energies. You in fact have the divisor between separate bosons, or 1/4 versus 3/4 of the energy of the field, or the middle of the longitudinal photon energies for that field. So it gives us a bisector for the two side lines, and again shows us the relationships between the square numbers and the quanta that form those square numbers themselves. There's a number of different mathematical formulations for it and expressions. Obviously we can take the changed geometry, or the re-expressed geometry of Pythagorean theorems or theorem, and re-express it in terms of of cosine rules, in which case again we can show the relationship in the case of a special cosine law of AB equals A squared plus B squared minus C squared, instead of adding them all together this time, separating them to form the Pythagorean theorem. We re-express it in terms and develop a special case of the cosine law, and this in fact can be applied to Kepler's law. It can give us Kepler's law in terms of the orbits of planets and their motions. This can continue on and on. We can in fact take equilateral geometries, we can halve them. We can then obviously take a third of each one, and we can develop musical notes or harmonies within the squared geometries or equilateral geometries of mass energy. This gives us again a connection back to music that's been sought over many years between things like orbits of planets, the energies of mass matter, how the conservation laws work. In fact, the scaling of mass energies is at the heart of the force laws, both the scaling and their superpositioning. Of course, this same geometry, drawn as a flat Euclidean geometry in this case, can be revisualized to represent the x, y, and z axes of Cartesian geometries, or c to the third relativistic geometries. Again, the relationship between c squared, c to the third, and c to the fourth, along with c itself, in terms of spherical coordinate systems, is expressed in another lecture, which I encourage you to view and look over before you enter into the reinterpretation of special and general relativity within physics using equilateral geometries. But all the relationships of inverse squared laws, etc., and harmonics can all be readily represented within the equilateral geometries of Tetryonics. And from them we can obviously generate the ternary diagrams of not only quantized mass energy itself, but also in terms of its electromagnetic fields, or its electric permittivity and magnetic permeability within that scalar field, which of course determines its charge, along with its quantized physical properties in terms of bosons or quantum levels, and energy momenta in terms of photons. Of course, all of these in every case will renormalize back down to 1, because it is the quantization of the scalar equilateral field into equilateral quanta that gives us the statistical probability of mathematics in quantum mechanics. And again, we'll explain this a little bit further on, but suffice to say, all these probabilities, no matter what they are directly related to the amplitude or the linear momenta of the system, and they all add up to give us a 1, or renormalize. Again, any field is a measure of its electric field, electric permittivity, and its magnetic permeability, or the magnetic field dipole that's created from their two magnetic poles. There are no magnetic monopoles within physics due to the equilateral geometry of mass energy and its electric permittivity and permeability fields. So from that quick basis in geometry of mass energies and the quantization, or how we can build up larger scale mass energy fields from mass energy quanta, equilateral in geometry, we can now develop a full understanding of the geometry of mathematics, and in fact reinterpret all of mathematics that's currently expressed in symbols and mathematical notations as a geometry. And this will give us a greater understanding of, or reinterpretation of, the mathematics within special and general relativity, which we'll cover coming up in future lectures. Obviously this must include by definition not only just integer numbers in the case of the quantization of mass energy, but also, in order to develop a fully rounded number theory from the geometry, we have to be able to explain things like irrational numbers and exponentials in terms of geometry. In the case of Tetryonics, we can obviously just continue to add these squared geometries together to form the basic constituents of all mass energy within our universe, i.e. 0-point fields, photons, bosons, matter itself, even large scale things like baryons. But as we add increasing numbers to the external geometry of each circle, we find a few numbers that can't be represented using equilateral geometries because they are non-equilateral in themselves. Looking at the ones that do specifically apply to Tetryonics, we can see that a single quantum of mass energy is equilateral, as we've discussed. Two of them, where they come together via their charge or the weak force, form a photon of energy. Again, noting that it takes two charged quanta to make a single frequency of light, or a photon, positive and negative to make a neutral photon. Obviously we can bring three equilateral geometries together. Not correctly shown in this case, this is a stylized view, but in the case of a quantum level there will be three in a row, or a odd number. Where we have four, we can obviously represent it as a tetrahedral geometry of matter, and this is in fact the picture drawn here is the geometry for the mass energy of matter, i.e. it's a flat Euclidean two-dimensional field made up of equilateral mass energies. Again, flat and Euclidean. In the case of matter to form, or three-dimensional matter, these three quanta would in fact interact via their charged geometries. They've already interacted by the weak force to form this geometry. They then interact via the charged geometries to form a standing wave geometry, or a tetrahedral standing wave, or the tetrahedron. The tetryon. Of course, if you look at where a number of tetryons come together, i.e. 9 of them, from the polar view you'll see this geometry occurring where we have 1, 2, 3 quarks. Again, a stylized view of the geometry of baryons, but if you print out the templates for Tetryonics, cut them out and fold them into tetryons, you'll be able to create the quarks, and again the baryons, protons or neutrons, or the antimatter equivalents. And looking at them from a polar view, you will indeed see that this is the geometry representative of all baryons. And of course, in stylized form, if we show the hexagon as a positive and a negative equilateral mass-energy field superpositioned, we have the basis for the vacuum energy field, or for charge interactions that give us the force laws of Coulomb, etc. Again, although it has the same mathematical formulation, Newton's law is not derived from the same mass-energy interactions that Coulomb's law is derived. Again, this is a case where the mathematics, although correct, fails to reveal the true mechanics that are at work. And in fact, that's what Newton said when he first formulated gravity. He had no way of understanding what caused the gravity. He could only model it using the math. This continued modelling has increased, and then mathematicians have relied on mathematical laws and logic in order to extrapolate from the known and proven laws of force in an attempt to create quantum field theories. In some cases this has led to some breakthroughs, but in all cases it has not provided a clear understanding of what's creating the mechanics of the system. And in fact, the mechanics comes from the equilateral energy momenta quanta, or mass energy quanta. As these quanta come together, they form, as we've said, a scalar, a squared scalar field of mass energy. And this follows the Tetryonic geometry that I call learning to count, or relearning to count. As you see along the left hand side of the triangle of the scalar field, we have the odd numbered geometries as you look transversely to its linear momentum, i.e. they're all odd numbers. The addition of all these odd numbers in order gives us the squared number energy fields, i.e. this is a transverse property. The square numbers are a scalar property of the addition of these transverse numbers. Of course, we can take the square root of these squared numbers and gives us a, in the case of quantized energy, mass energies, it gives us a integer number in all cases. And you'll note that the integer number is reflective of the linear momentum of the system. The number of quanta, mass energy quanta within a system, and their constituent energy momenta is what gives us velocity for matter in motion, or V. Again, there is a relationship between the number of quanta, or the Compton frequency, and the de Broglie wavelength of each quanta. As you increase the number of quanta in any fixed equilateral geometry or field, you obviously have to change the wavelength or the physical geometry of each quanta, i.e. you're compressing more and more quanta into the same physical field, because these fields are all a measurement of time in the case of mass. So as the frequency increases, the wavelength will decrease, and the frequency wavelength are related through the velocity. In the case of energy within a vacuum, that velocity is the speed of light, or c. Again, termed within Tetryonics more correctly to be the natural velocity for energy. In the case of a photon, there would be two charged geometries back to back, a positive and a negative charge field, creating bidirectional radiant, or energy that radiates in two directions as a result of the linear momenta of the system created by their quanta. If we look at the photons themselves, or a longitudinal measurement of any scalar field, whether it's a single field or a EM field, the longitudinal measurement is a measurement of the photon energy, i.e. the repeating wave sets from positive to the next positive, or from negative to the next negative, etc., or from magnetic to magnetic. Any repeating set obviously requires two quanta, or a photon of energy. Looking at it in terms of a charged field, or a boson of mass energies, we can quickly see that these photons follow a pattern. They start from the maximum amplitude of the wave and they diminish outwards in both directions from the median of the wave as n-1 in terms of the photon. So we've lost half a photon here. We've lost an entire photon when we get out to here. And by the time we get all the way out to the edge, there are no photons. There is in fact only a half wavelength photon, which of course is a 0-point field, or a W boson of one charge or the other. This is what we call a normal distribution in mathematics. When we measure this normal distribution, and again if it was measured in terms of energy quanta instead of photons, we would just have integer numbers instead of half integers along this base, but the distribution will be exactly the same so far as the mass energy of this field. If we measure this physically, this field, with our macro scale instruments, even our best, we will not obtain a equilateral geometry. What in fact we obtain will be a series of measurements which, when we graph them, will give us a bell curve of the energy momenta, or the mass energy distribution within this equilateral field. So again, the Tetryonic geometry reveals that the smooth bell curves, or the graphed bell curves of mass energy or energy momenta distributions within quantum systems, is in fact not a smooth curve or a bell shape. It is in fact a equilateral geometry, and it is both our measurements and our mathematics and our graphing of the measurements that produce a erroneous idea of what the geometries are at the quantum level. One of the interesting quirks of quantum mechanics, and you come across a few within the geometries, is the fact that as you transition between square energy levels to create spectral lines, you're in fact taking a fractional measurement of the energy and releasing it. In the case of we have a base 10 energy momenta field here, but in the case of a N9, which is this level here, the second highest, if we were to transition between N9 and N1 in the Lyman series of spectral lines, we would in fact give up 80/81ths of the scalar field, i.e. we start at 81 and we have to give up 80/81ths of the energy, total energy of that field, to obtain a final energy of 1 quantum. In doing so, we are in fact giving up 0.987654321 of the field. It's just a mathematical quirk. That 80/81ths gives us that number sequence, and we can express that as the square root, obviously. In this case, we just put it down here as 987654321, which matches up with the square root integers or linear momentum of the system for N9 to N1 energy transitions. And this is of course a specific Balmer spectral line that's produced, Lyman spectral line that is produced. Lyman obviously being transitions to N1 energy levels. It's outside our visible lights. The Balmers are within our visible light spectrum. Looking closely at the basic mathematics, obviously we have integer numbers, which are just 1, 2, 3, 4, 5, 6, and all of quantum mechanics, as the name suggests, is made up of quantum integer numbers of energy or mass energy. In this case, because of the equilateral geometry, these integers always form square numbers so far as the scalar field or the total energy of the scalar field is concerned. We can obviously express these odd numbers as a number sequence where any number or any odd number is simply the mathematical formulation of, or the result of the formulation of 2n minus 1, and the square numbers are the sum, sequential summing of odd numbers from 1 to n. It could also be expressed as 2n plus 1, but because we start with a 0 energy field, we don't actually show the 0. We start at 1 and go up. We state it as 2n minus 1 because this is most fitting when we describe the normal distribution. Again, they start at n, for representative of the linear momentum or the amplitude of the wave, and they diminish as n minus 1 as you work out laterally from the linear or the medium number, rather than n plus 1, which would be incorrect. The odd numbers, as we've discussed, are in fact anything between 1 and infinity, and they follow the pattern n minus or 2n minus 1. Again, they can have either positive or negative charge geometries, but because they are an odd number, the final geometry will always produce either a positive or negative charge, and these are referred to as W minus or W plus bosons because of their net charge. Again, if you try to divide a odd number by a boson field, odd numbers, by a longitudinal measurement, i.e. photons, you will get a fraction, i.e. a half, showing that the transverse is different to the longitudinal measurements of mass energy. As we mentioned, historically pi is referred to, or is correctly referred to, as 3.14159, and it's a relationship of the diameter of a circle to its circumference. In the case of Tetryonics, because we talk in pi geometries, in the case of photons, we'll refer to them as tau geometries or tau radians, where we have a positive and a negative charge geometry or bosons combining via the weak force interaction to give us a photon of energy. Again, photons are mass energy geometries. They are in fact matterless. They do not have a three-dimensional component or a Z component to their geometries. They're a Euclidean, flat Euclidean planar mass energy that radiates bidirectionally from its source point. And again, measurements, physical measurements of the electric and the magnetic field permittivity and permeability give us the familiar sine wave curvatures for electric and magnetic fields, and they have a phase relationship of sine and cosine with respect to the electric and magnetic, and sine and cosine with respect to lateral displacements of photons within the EM fields. As we mentioned and highlighted, two charge quanta or two Z bosons, two 0-point fields come together, so two W bosons come together to form a Z boson or a photon of energy. There is a geometric difference between Z bosons and photons, and this is simply in the arrangement of the positive and negative charges. In the case of photons, they come together and interact via the weak force to form this diamond shape geometry with a distinct Evans photomagneton in the center, or a magnetic moment. In the case of neutral Z bosons, they come together side by side, a bit like a normal boson, but they're missing one of the charge. They're an even number of charged geometries, not an odd, so they then have a neutral charge within that geometry, and they're a transverse measurement because they are a boson, whereas photons are a longitudinal measurement. Again, as we saw with the quantum levels or the boson, transverse boson measurements, we now see that we can create a color coding for the normal distribution of photons within any EM wave, and it is distinctly different from the transverse quantum levels. This forms the basis of wave amplitudes and the statistical probability of quantum mechanics, or particularly QED, Obviously, as energy is added to a EM wave, it's added via photons made up of bosons. But each EM wave, because it's made up of photons and measured in that sense via its electric field interactions, is a even numbered, or has even numbered quanta because of its positive and negatives, and this pattern repeats, well, the pattern of electric permittivity and magnetic permeability of photons is expressed as the photon or even numbered quanta of mass energies is added together to form an EM wave of higher and higher frequencies. It's expressed again in the net positive and negative charges of the bilateral radiating energy momenta within the fields, or the photons, and these all add up to, again, a neutral energy field. Again, measure it again transversely. You have a measurement of the quantum levels of the field, or its bosons. Measured longitudinally, you have a measurement of the photons, or the E fields, and their propagation. But in both cases, an EM wave is made up of 2 pi squared energies, or an even number of photon quanta, or an even number of quanta themselves. The triangular numbers that have historically been expressed as 1, 3, 6, 10, 15, i.e. the Greek method of mapping the points of the triangles within the geometry, can now be replaced with tetrayonic formulations of transverse odd-numbered bosons and scalar squared-numbered mass-energy geometries, all forming triangular energy distributions in the form of a bell curve or a normal distribution of energy momenta or mass energies. Again, as we've just mentioned, it's the odd-numbered geometries, or the quantum levels, that combine in sequence to form square energy levels. You cannot increase a N4 or 16 quanta energy level by adding another 4 or 5 quanta or anything like that. 1, 3, 5 and 7 have already been taken. In order to increase the energy level, you specifically need a 7 quanta to increase it to energy level 5. And it's this specific number of quanta within each quantum level, or the odd numbers within the geometry, that gives us our spectral lines and the photoelectric effect as described by Einstein. Again, he described it in terms of photons, or longitudinal energy measurements, quanta of energy. Planck described his heat law in terms of h nu, or the bosons, the quantum levels of the spectral line emissions, or the heat emissions in his case. We can obviously apply all of these formulations, these geometries, to the formulation of mathematics for mass energy. We can express it again in the case of Tetryonics through the universal field equation for mass, energy and matter, in which case the energy component of the electromagnetic field is shown to be is formulated as mass alpha nu squared, or where mass alpha is in fact Planck's constant, kilograms square meters per second. Nu squared is of course the Compton frequency. Reading at from the base, we can see the classical formulation of energy, which is mass velocity squared. They're the same things, because for any velocity you need a square number of quanta. So again, the geometry is the foundation for the mathematics, and in this case, by using the geometry, we reveal the hidden constant alpha, or the equilateral geometry of mass energy within physics itself, something that's been hidden in the mathematical formulation. Again, looking at the distribution of energy, whether it's longitudinal distribution or transverse distribution of quanta, we can show that they form square energy geometries within the equilateral EM field, which then of course have charges as a result of the polar magnetic pole arrangements within the magnetic dipole of each field, and they contain linear momenta as well as quantized angular momentum. In all cases, these geometry, whether it's bosons or photon measurements, form a normal distribution, with care being taken to distinguish between the transverse bosons and the longitudinal photons in each case, i.e. two transverse quanta for every photon. But in all cases, they can then form probabilities within the normal distribution, and these probabilities will always renormalize back to 1 when summed up for the scalar mass energy measurement of the field. And again, any measurement of energy per radial or per unit of time in a spherical coordinate system is a measurement of mass under Einstein's formulation or equivalence formulation for mass energy. Obviously, a unique thing to arise out of the equilateral geometries of Tetryonics is the fact that the square roots of all scalar fields can be easily drawn and calculated for, irrespective of their mass energy contents. This means that in the case of negative charged fields, i.e. the left-hand side of the drawing, we can in fact calculate for the square root of -1 as a physical reality. In mathematics, the square root of -1 is a imaginary number. It cannot exist mathematically because it will be the physical reality is it's a negative number because it's a negative charged mass energy field. But in mathematics, the squaring a negative number will give you a positive, and mathematically that would convert, squaring the linear momentum of the negative charge field would give you a positive charge field, and that's not the case. In the Tetryonic geometry of mass energies, it remains a negative charged field. We're just calculating for the linear momentum of that energy field, in which case we can in fact, as I've mentioned, calculate or determine a physical reality to a previously imaginary mathematical number. And we use this geometry to in fact give meaning to Euler's formula, and we in fact show that it is a mathematical expression of photons of energy within the EM fields. We've now clearly shown that all real numbers within the number theory and within mathematics itself can be expressed in terms of equilateral mass energy geometries. Whether we choose to measure them or express them as quantum levels or bosons or transverse mass energy measurements of a field, or the longitudinal photonic measurements of energy within any EM field, we can in fact develop a numbering system from 0 to plus or minus any integer number for any scalar field of mass energy or force that's created through the energy momenta of these fields. And in fact, obviously, from this numbering system, we can indeed show that the geometry sets no upper limit. These numbers could in fact increase to infinity, in which case the energy momenta of the scalar field produced by a velocity of infinity would be in fact be infinity squared. Again, another geometric representation of something that up until now has only been shown mathematically in symbols. All of the math of mathematics, all the symbology of mathematics can be reinterpreted in terms of numbers of quanta within equilateral scalar fields, and the physical properties of these fields, the forces, the energy, momenta, mass, properties of any physical system based on these equilateral geometries can be shown geometrically as opposed to mathematically. Over time, it will probably become more natural to express it geometrically, because again, the geometry forming the foundation for the math also sets the grammatic or the logical rules for operations within the math that have struggled in the last century. Obviously, in the case of equilateral or tetrayonic geometries, we refer to the square number geometry within the equilateral geometries. They're all flat pi radian geometries, and we can, of course, map them back to the spherical coordinate systems of time measurements. But the equilateral geometries retain the classical equilateral properties of height, same length sides, same angle interiors, etc. In the case of Tetryonics, we can have inscribed and circumscribed geometries or circles within or within relationship to the equilateral geometries of mass, energy, and the quanta. In these cases, they refer to converting energy measurements into measurements of mass via Einstein's formulation of mass energy equivalence, E equals mc squared. Or we can in fact describe the equilateral geometry or the quantized angular momentum of mass energies as a vector rotation within the geometry themselves, in which case we show that the relativistic measurement of time, or the unit of time, is in fact just the quantized angular momentum per c squared spatial unit. Again, angular momentum divided by c squared will give you a unit of seconds. Again, showing that time is no more than a mathematically misinterpreted measurement of quantized angular momentum per spatial geometry, or another way of expressing it is time is a measurement of the foundational geometry of charge. As we just mentioned, the circumscribed triangles, or triangles outside circles, careful with the terminology here, inscribed circle, circumscribed triangle is different to a circumscribed circle with an inscribed triangle. You'll see that shortly. But in the case of circumscribed triangles or inscribed circles, as I've just mentioned, we can use the inscribed circle to represent the energy flux of energy within any 0 point field or any quanta of energy. Of course, this flux of energy gives us an electrical equivalence of a short-circuited quantum inductor, which of course will give us charge and a magnetic dipole. So we can use that to determine the electrical properties of quantum mechanical particles and fields. The circumscribed circle, which I mentioned on the previous page, is where the circle or the spherical coordinate system in terms of C is in fact used to convert energy measurements to mass measurements. It's where per unit of time, or the measurement, in this case the measurement of the natural velocity of energy, the spread of a photon of energy per second, gives us a radial measurement of time of c squared, or a spherical geometry. And within that spherical geometry of c squared, we measure the mass energy, or the energy content of the system, and energy per c squared gives us an equivalent mass content for that equilateral energy. Obviously, in the case of bosons, we're measuring odd-numbered quanta within the scalar field, In the case of the longitudinal measurement, we're measuring the photon content of the same field. And again, they form natural distributions of either integer or tau integer numbers. Again, highlighting what we've just said, charge is a inscribed geometry within the equilateral scalar field, and the spherical coordinate system is the circumscribed circle. Again, giving us, within the equilateral scalar field, it gives us measurements of mass, energy, and charge, along with the quantization of the energies of that field. Of course, we can also calculate for the linear and angular momentum, bearing in mind that the inscribed circle is just a representation of what is truly the equilateral geometry of the field. We can obviously, of course, break up equilateral geometries into two or dual right angle triangles, and we can map the classical measurements or geometries and relationships, trigonomic relationships for right angle triangles, into equilateral geometries. And note that we have two of everything in order to form the equilateral geometry. So in the case of most formulations for trigonometry, where we've expressed relativistic formulation, etc., as a right angle triangle, we can in fact reorientate the right angle triangle and double it to give us the true mass energy geometry or quantization of the energy involved in the process or the physical system. The laws for sine, cosine obviously still apply to equilateral geometries. We can see that the sine would in fact be the altitude of the linear momentum of the system. The cosine could be a measurement of the magnetic dipole versus the electric field. Sine, cosine, they're orthogonal to each other, 90 degrees out of phase. And likewise, a lateral displacement of measurement of any EM field is a sine-cosine relationship because of their lateral displacement. And tan is obviously just the hypotenuse within the equilateral geometries. They can all be applied as they stand, but obviously you just have to be careful of the fact that you are applying right angle trigonomic functions to equilateral geometries. So you have to take into account the change in the geometry itself and the relationship, and particularly what it is that you're measuring or calculating for with respect to the equilateral geometry of the scalar field. All this again can be applied to the circumscribed and inscribed circles within, or spatial coordinate systems within equilateral or scalar mass energy fields. And in this case we can see the relationships of the square root of 3 to the golden ratio, etc. All of this, again, the golden ratio in this case would be slightly higher than the diameter marked here, but the diameter, the inscribed circle of a scalar field, is half the size, half the area of the circumscribed circle formed by the diameter, because obviously they're both related through pi. One is the radius, the other one is the diameter, and it's this geometric relationship between circles, radius, diameters, to equilateral scalar fields inscribed within the radius diameter relationships of circles that gives us the inverse squared law and the scaling of energy per unit of time. Obviously these circles form the basis of spherical coordinate systems, measurements of 1 second versus 2 second, and the scaling of the energy is proportional. So the energy, equilateral triangle of energy that will be inside the first circle, marking 1 second, would in fact be the size of the illustrated triangle 1 second later, where we've gone from the radius to the diameter, or we've doubled the radius to get the diameter. They're all trigonomic functions, and the geometry relates these trigonomic functions back to the quantized energy, momenta, or mass energies of the scalar energy fields. We can obviously show a finite series of numbers using the same equilateral geometries as I just mentioned, and the relationship of one measurement of one unit of time to the next unit of time, or one geometry to the other. We can either increase a mass energy measurement of a scalar field and take it in 1 second, 2 second, 3 second increments, in which case the energy spreads out according to the wavelength frequency relationship of the velocity of the energy, c in the case of energy in a vacuum. Or of course we could work the other way and take a measured system and we could break it back down into smaller and smaller increments of that system to develop a infinite series, as measured here, to give us an approximation of the energy, although in Tetryonics we can calculate the exact energies due to their equilateral geometries. In the case of Maxwell's formulation, he showed that 1 over c squared is in fact an electromagnetic E-field permittivity by magnetic permeability, gives us 1 over c squared. This can be shown to be the case of a c squared spatial geometry of mass energy. When inverted, i.e. cut out the circle, fold it back in on itself, we create the familiar E-field permittivity and magnetic permeability, so 1 over c squared geometrically. In Tetryonics we just call it inverting the circle, or inverting the spatial measurement. Geometric square roots, traditionally because of the terminology square numbers being reflective of a square geometry, have now been redrawn or retermed within Tetryonics to be where square numbers are in fact equilateral geometries. They can be square, they can be equilateral triangles, they can in fact be hexagons, for example. We're all made up of geometry made up of equilateral triangles. But we can calculate for these square roots, the square root of 2 obviously being the diagonal of any squared geometry, and the square root of 3 on 2 is in fact the height of any equilateral geometry. Again, you can calculate this from the trigonometric functions for the right angled triangle, bearing in mind that you have to divide by 2 because this is only half. This height here of the right angled triangle is half of the height of the base of the equilateral triangle. And again, we can quickly show geometrically the relationship of the square root of 1 to the square root of 2 to the square root of 3 within geometries. Of course, they all come back together, as we mentioned before, to force us to reinterpret and relearn how to count with an equilateral geometry within physics. And this, along with the foundational equilateral geometry of energy itself, or mass energy, is one of the most important breakthroughs that Tetryonic theory gives us in understanding quantum mechanics and the physics of matter in motion within our universe. Classically, these were interpreted in the early days of physics mathematically by Newton and Leibniz. In the case of Newton, he was calculating his laws of force in terms of the linear momentum of the system, or specifically through changes of the linear momentum. F equal ma is just a way of re-expressing, or a concise way of expressing the forces is due to or creates a change in the momenta of a system per unit of time, or changes the velocity of the system in direct proportion to the mass of the particle in motion due to the force that's applied to it. All of his laws are in fact just re-expressions of the measurements of linear momentum of any system. Leibniz, of course, worked on the scalar energies of the field, and his formulation, where Newton's was momentum equals mass velocity, his formulation was energy equals mass velocity squared. Newton's was simply the square root of the scalar energies. And again, the mass of the energy as expressed by Einstein is E equals mc squared, i.e. a spatial measurement, or a per unit of time measurement of energy, is equivalent to the mass of the system, or specifically its inertial mass. Its relativistic mass is the result of its inertial mass plus the mass energies of its chem field, or its kinetic EM fields that result from its motion. But again, all the relationships of mass, energy, velocity, scalar fields, motion, etc. are shown through equilateral geometry of Tetryonics, and in fact shown possibly even clearer than the mathematical formulations, particularly when it comes to things like square roots, which are hard to define, even though they can be defined graphically, as shown here, in relationship to each other. They're much better shown in terms of force, or the square root of scalar fields, as shown within Tetryonic equilateral geometries. And Tetryonics, of course, can give us an exact value for all linear momenta within the system, as well as its quantized angular momentum. As we mentioned previously with Euler's formula, we can in fact give a physical reality to the square root of -1. And of course we've already shown a physical reality of pi radians with respect to equilateral geometries. So we're starting to bring the irrational, disparate components of Euler's formula back into a physical relationship within the energy momenta and the geometry of physics itself. And whilst Euler's formulation in its various forms, some expressed here, some on other pages, have been known for a number of centuries now, the beauty of these numbers has never been fully interpreted outside of mathematics itself. The mathematicians have understood the transcendental properties of this formulation, where we bring together things like exponential growth, imaginary numbers, trigonomic functions such as pi, and sine-cosine relationships, as well as imaginary numbers like the square root of -1, into a formulation, into one mathematical formulation, where they all combine to give us a single number. In this case, e to the I pi gives us -1, or the negative charged geometry of mass energy in a photon, and e to the I plus 1 will give us neutral, or -1 charges plus 1 positive charge will give us a neutral mass energy content of a photon. So Euler's formulation in fact is a mathematical description of the mass energy geometry, or the energy momenta, linear energy momenta, of an EM wave. In the case of pi, it's describing the equilateral geometry, or the quantized angular momentum of the system. In the case of the square root of -1, it's giving us the linear momentum of the negative charge boson of the photon. In the case of e to the I pi plus 1 equaling 0, it's giving us the charged boson geometries of the photon, again what we call tau geometries. And the sine-cosine relationships are giving us the relationships of electric to magnetic fields, as well as the relationships between individual photons as they're measured within the normal distribution, or the bell curve, of the EM wave. Tetryonics, again as the foundational geometry behind the math, shows us what the mathematics alone could not show us. The math has been known for centuries now, but its true properties were never understood, how they came about or what they were describing. The Tetryonic geometry gives us that explanation, and in fact it not only gives us the explanation of what this equation is describing, it also sets the rules for how this equation can be manipulated mathematically to give us a more advanced understanding of the physical components of EM waves, or the energy momenta, mass energies, properties of these fields. As we just mentioned, the square roots of scalar energy fields give us integer numbers, or the linear momentum, the amplitude of the EM waves in the case of transverse waves, the linear momentum in the case of longitudinal waves. And squaring the linear momentum, or the amplitude, gives us the probability, or the number of quanta within that wave, and the quantized angular momentum gives us the geometry of that distribution of energy momenta within that field. So again, the geometry takes the mathematics one level further by giving us the physical foundation of the mathematics. In the case of geometric means, the equilateral geometry simply shows us that a geometric mean is an expression of the force, or the linear momentum, between two objects, or the force created by the superpositioned chem fields. In the case we have two charges. Here in the case of Coulomb's law, force law of electric charge, and we see that it is the superpositioned E fields of the chem fields that interact to give us the forces between the two charges. The magnetic fields do not interact in the case of the charge interaction. There is an interaction available in the case of Ampere's law, where the magnetic fields superposition with themselves when particles move in opposite direction or the same direction within conductors, and in that case the force law, or Lorenz's force, is expressed through the superpositioning of magnetic fields. Coulomb is the electric field, Lorentz is the magnetic field forces. Again, if you look at it in terms of the equilateral geometry and the mass energies, you have a force expressed by the square root, or the linear momentum of the system, that's created by the energy momentum content within that field, or the quanta, and superpositioning it as in charge by charge, and the distance between them, so far it will determine how many mass energy or energy momenta quanta interact within that field geometry. And in every case we see that the inverse squared law gives us a diamond-shaped geometric mean geometry. Again, linear momentum is the square root of an equilateral geometry. Quantized angular momentum, or scalar angular momentum, is in fact the equilateral geometry itself, with the scalar being the product of the quantized angular momentum within the field, or the number of quanta, as indicated with the orange triangles here, the golden triangles. Of course, it's been known for a long time that Newton formulated his inverse squared law before Coulomb formulated his. We have precise measurements for Coulomb's. We don't have a precise measurement for Newton's. And of course the mystery's always remained that the formulations for charge interaction and gravitational interaction, or attraction, sorry, there's no interaction, it's only attraction in the case of gravity, are identical. One is a measure of the attraction between mass matter, and the other is the attraction between charge of matter. This has remained a mystery for a long time. In fact, Tetryonics shows us that gravitational attraction is a convergent force between mass matters, geometries, but it's the force that results from the energy densities created by matter within vacuum energies. And it is in fact not, whilst it is generated by equilateral mass energy quanta at the quantum level, it is a completely different mechanism, but results in the same equilateral geometry for the inverse squared law. However, as we've noted, different mechanism for creating the forces, and in the case of charge it's a interactive force, bidirectional with convergent and divergent energy momenta, and in the case of gravitation it is a strictly convergent force between separated mass matters. Of course, where we superposition chem fields or any energy momenta fields, mass energies or energy momenta itself, where the phases of the energy momenta are in phase, we create a additive force, or where they're out of phase, it creates a nullification of the forces or a weakening of the forces. And again, this superpositioning of chem fields or charges can be put to use in quantum computers. We can of course develop a multiplication table using Tetryonic geometries, but I still find the traditional squared or geometries of mathematic tables friendlier for learning purposes than I do the equilateral geometries of Tetryonics. But again, Tetryonics can give us a square table where we just measure the diagonals of the base and the side to give us our squared numbers. It gives us a more compact table than the same thing in square numbers because it's not repeating itself, but it's not as easy to learn or as intuitive as the square geometries. Of course, we can apply the same thing to give, in the case of superposition, square numbers or multiplication tables, to give us tables for square root medians, where we read the numbers diagonally to get that, and we can get integer mediums, etc. Again, charge versus photon geometries, and they all relate back to square numbered geometries or square numbered equilateral geometries, again highlighting that both squares and triangles are equilateral geometries. And as we've mentioned before, the fractional numbers, where we jump from one square number to another square number of energy momenta within a scalar field, gives us the spectral sequence or spectral series of light with elementals or elements. Of course, this has been formulated historically using Rydberg's formulation, as noted at the top. Everyone's understood that the mathematics works in the case of 1 over n squared transitions. These of course can be expressed as lowest common denominators or re-expressed, and they can be expressed as equilateral geometries, but it's the geometry of Tetryonics, of the equilateral square energies, that shows us what is physically going on, and it gives us the formulation. In fact, we can use this geometry to create a visual, easy to solve mathematic or geometric relationship rather than the poorly understood mathematical formulation for the same thing, where we calculate in terms of wave numbers instead of wavelengths. We can obviously quickly see the wavelengths that change as we increase the quanta between the energy transitions. And of course this is explained in a lot more detail in the lecture on spectral lines and quantum energy transitions in chemistry. They all follow, of course, E equals mv squared relationships, where the m can be either the mass of the energy field, in the case of chem fields or charge interactions, or it can be matter in terms of kinetic energies of photoelectrons, etc. Again, care has to be taken when stating mv squared, whether you're referring to matter velocity squared or mass velocity squared. There is a distinct difference, and it's again a sign of the superiority of Tetryonic geometries that we can discern the difference between mass and matter and energy using the geometry where historically relativity has lumped these three distinct physical properties together and termed them simply a stress energy tensor or an energy density per spatial measurement. As we mentioned before, the fractions within Tetryonic geometry are all changes in square energy fields. If we want finer and finer fractions, we can just specify a single equilateral geometry and then whatever squared energy geometry we wish, or energy momenta quanta within that field that we wish to calculate the square root. And of course these are all changes of the bosons, odd-numbered bosons within the equilateral geometry. Again, it shows us that fractional changes of square numbers can in fact be re-expressed as changes in odd-numbered quanta within that geometry, or those square numbers. Of course, we can express a lot of the irrational numbers that come up in mathematics, such as sines and cosines, square roots and square root fractions, etc. Pi itself. All these irrational numbers can be shown to have a geometric basis within Tetryonic physics. Of course, the main one being that odd number transverse mass energy measurements add up to form square number energy, scalar energy geometries. And that bosons are odd numbers, energy itself is the square number quantas, square root is linear momenta, photons give us distributions of energy as do bosons, and transverse versus longitudinal measurements give us differing physical properties for the same energy fields, just as differing spatial coordinate systems give us differing physical properties of energy, i.e. mass or matter. Again, they're all geometric properties of physical systems, and the mathematics is simply a human attempt to describe this geometry when we didn't know what the geometry was. Now that we know the geometry, we can say that the equilateral geometry forms the grammar for mathematical language within physics, and in fact over time we can in fact do away with the mathematics as the path to learning physics and use the geometry as the path, as a visually intuitive path for physics, for learning physics, and we can use the mathematics simply to rigidly describe the various geometries. We can, of course, as we've alluded to before with infinite series, we can describe exponential growth within a system as simply the mass energy or equilateral mass energies of a system as measured per spatial coordinate system or per unit of time. In this case we've chosen the time, which of course will give us a spatial coordinate system based on the speed of natural speed of energy, or this in a vacuum, c. But we can choose any coordinate system that we so deem. We can do a two-dimensional one, in which case we get measurements of mass, exponential mass growth for the exponential energies, or we could choose c to the fourth or c third to give us Cartesian or relativistic matter formulations for the energy, or measurements of matter for the energy within the same system. Again, mass, energy and matter, as discussed in previous lectures and will be discussed again, are all related to each other through the velocity of propagation of energy itself, or c. Energy per c squared is a measure of mass. Energy per c to the fourth is a measurement of matter. Of course, all the logarithmic functions can be calculated or used specifically for physical systems of mass energy, should be redrawn in terms of equilateral geometries for those mass energies and the quantized component. If we divide by Planck's constant, we get the equilateral geometry of the quantized angular momentum, or the quanta within that system, and it will be a square number. And we can solve for the mass energies, or the mass energy, the energy momenta of any scalar system or any physical system, using the geometry. And of course, in the process, we will get logarithmic expansions developed, etc. Of course, utilizing the logarithmic and infinitesimals was first developed with Leibniz, who of course concentrated on the scalar energies, and Newton formulated his work for integral calculus using the linear momentum of the system. So one is a differential calculus of units of length, or measurements of length, velocity, speed per unit of time, distance per unit of time, dv dt, whereas Newton developed integral calculus from measurements of momentum, square root versus squared numbers, or scalar versus linear. They're all different ways of looking at it, and of course the familiar kinetic energy equals a half mv squared comes from the scalar measurements, as does the magnetic moment of systems, now expressed within Tetryonics as being half of the scalar energy of any system, or any chem field of a matter system in motion. In the case of Newton, where he developed differentiation, obviously he was just simply calculating for the force that changes in momentum create, or that the changes in momentum that are created by the application of force. We can see it change in distance over change in time for the velocity, or change in velocity over change in time to give us the acceleration. Meters per second, linear versus linear measurement per scalar field. Again, easily drawn with Tetryonic equilateral geometries. Historically a bit harder to comprehend what the second squared was referring to without the geometry. But we can simply redraw mass, energy, matter, velocity relationships, quanta, in the case of quantum mechanics, as an equilateral geometry for the mass, energy, momenta of any system that has a force exerted upon it. In this case, obviously, the mass matter of the system isn't drawn here. This is simply the chem field, or the representation of the energy of the chem field that's produced by any force. Of course, integration simply being the number of, or the squared number of quanta within a system. In the case of a transverse measurement of bosons or quantum levels within a field, it'll be odd number energy geometries that form the bosons or the quantum levels, and the summing of these, or integration of these odd numbered bosons, will give us the squared energy fields, as indicated here with the Tetryonic mass, energy, velocity, force geometry. Or of course we could measure it longitudinally with photons of energy, momenta, in which case again the summing or the integration of the probability or the amplitude of photons within the field, within the scalar field, will give us the normal distribution or a probability of 1 for the total scalar energy momenta of the field. Again showing us integration in a geometric term, geometric method, visually rather than the traditional integration of area under a line, mathematically. Of course, summing an infinite series can be expressed geometrically, as we've discussed. We can show that this is a renormalized field of 1, and we can approximate that field by taking smaller and smaller sections of the field. In this case we have 1. We can then take 1/4 of that, add up the quarters to give us 1, or we can take 1/16 of each quarter, add them up to give us 1, or we could take thirds, as illustrated by the various colouring of the equilateral geometry, to again give us 1. In each case we're summing or integrating the area or the scalar area of the field in terms of its various properties or geometric properties, physical properties, and in each case we're renormalizing to give us a total of 1 or an approximation of 1, depending on how far we integrate this infinite series. In the case of Tetryonics, we usually integrate in groupings of square numbers, which of course is the basis for Rydberg's formulation for spectral lines, the inverse of a infinite series, or a change between a fractional change between the square numbers of any scalar field. In terms of velocity, which is just meters per second, we can then show the same thing using geometric properties or geometry of mass, energy, momenta. Again, noting that the linear momenta is what we're looking for here, as opposed to the quantized angular momentum, which is the geometry. Velocity squared is a scalar. Velocity squared, square meters per second squared, is a scalar measurement of energy, mass energy, whereas velocity, meters per second, is the square root measurement of the scalar energies of the field that produce or result from velocity or motion. Acceleration, changes in velocity, again can be represented with second squares being the spatial coordinate system used. In relativity it's referred to as c to the fourth. In classical mechanics it's seconds squared, just like seconds in classical mechanics is c squared in relativistic formulations, where we're just developing a spatial coordinate system from the motion of energy in a vacuum in this case. We can show the how force will create a velocity or a change in velocity, change in momentum within any system by changing the quanta within the scalar energy field. Obviously it's the number of energy momenta quanta within this field with their associated linear momenta in each quanta that gives us the net force of either acceleration or deceleration. Again, you can describe deceleration as a change in odd numbered quanta. You obviously have to release odd numbered bosons in order to change the square numbered of quanta within the field. In the case of accelerating, you have to add odd numbered quanta. Again, the mathematical formulation for odd number changes is different and gives no real clue to what the processes are, other than the fact that we're changing it by an odd number within the squared numbered fields. But the Tetrayonic geometry gives us a clear understanding of the input or release of bosons of energy within squared scalar fields, energy fields, to give us changes in energy momenta or accelerating fields or matter. And again, we can relate this all back to geometry and mass energy relationships within physics. As we've discussed, we can obviously express momentum a number of different ways geometrically as we can within the mathematics of physics, but in all cases what we're solving for is the square root of the scalar field. Whether we calculate this as a energy momentum, which is just a square root of the scalar field, or the mass velocity, which is just a measurement of the geometry of the energy field per unit of time, giving us mass and velocity through the relationship of the squared number of energy momenta within that field. Again, in all cases, no matter how we calculate for energy or momenta within a system, or mass velocity, it's a geometric relationship at all times of equilateral energy momenta within any system. And again, this is expressed in Tetryonics with the unified field equation as mass alpha quanta squared, which of course can stand for Planck quanta squared or mass velocity squared, with the square root being Planck quanta linear measurement of photon energy, or it can be mass velocity, a scalar measurement of the field and the force it produces. Squaring the square root, or the linear momenta, gives us a measurement of the scalar energy. And of course that's just a geometric relationship between mass, energy, velocity. We can quantize that obviously using the equilateral geometries, giving us mass geometries or Planck's constant, to give us the quantized or quantum mechanical interpretation of classical mass velocity and the relationship between the two, between classical and quantum mechanics, thus unifying the fields. This energy momentum relationship, geometric as we've discussed over and over, simply relates mass energy, scalar fields or scalar properties, to the quantized equilateral geometries or the Planck's constant of the scalar field. Again, showing us that whether we're taking a quantized view using Planck's constant or a scalar view using mass, a measurement of energy per spherical coordinate system, or per second squared, matter would be per second squared. Irrespective of what we use, whether it's a classic or a quantum measurement, the geometry remains the same, as does the energy content or the scalar content of that field. All that is changing is our interpretation of this geometry. The geometry is fundamental to the mathematics. And in fact, we can pull apart Planck's constant and show it as a measurement of mass alpha or mass geometry, and the number of geometries within any scalar energy field, just as we can measure it in terms of the velocity created for any mass. Again, square root gives us Newton's formulation. The scalar field is Leibitz's scalar formulation of the same thing. And we can relate energy through mass velocity squared or momentum velocity. Of course, in doing all of this and equating everything mathematically back to its foundational geometry, we completely remove right-angled triangles and the way from relativistic mechanics, and this is the way it's been the mass energy velocity relationship and matter kinetic energy velocity relationship in terms of relativistic and mass energies has been drawn. This is a misleading and confused interpretation of mathematics. The foundational geometry is equilateral, not right angle. And in fact, in the case of equilateral geometries, as we've discussed, the right angles. It takes two right-angled triangles to form an equilateral. Equilateral geometry is the foundational geometry of all mass, energy, matter within physics, along with its motion. In the case of motion, we can also determine inertial masses by the amount of force or the energy that's required to accelerate mass matter from any particular velocity to another, or change the system's momenta. Again, whether you're measuring the energy of the force applied, or the change of the energy in the system, or whether you're measuring the linear momentum of the system, is simply a change in the mathematical expression of the underlying geometry involved. And again, this can be also formulated in terms of the electrical properties as well as the physical properties of mass, energy within a system. But in the case of changes of force or changes of linear momentum within a system, which is how Newton expressed his laws of force, F equals ma being the second one, it's simply changes of the momenta, which is the square root, the linear momentum I should stress, the square root of the system. Squaring the linear momentum gives us the energy content, which can be re-expressed in terms of mass velocity squared. Again, in terms of mass velocity squared is the energy, mass velocity is the square root of the system. And this shows us, of course, that in terms of mass energy, not only classically is it the square numbers that form the scalar mass of all matter, or the charged geometries, it can also be expressed in terms of quantum mechanics, where we quantize the angular momentum or the geometry of the scalar fields with Planck's constant to give us a quantum mechanical interpretation of the same scalar or linear mass energy fields or forces, thus uniting quantum mechanics with classical mechanics through equilateral geometries of Tetryonics. Of course, in terms of mass, energy, matter, what we're going to show here is a very specific example of how the geometry is superior to the mathematics. And in this case, what we're showing is the relationship between mass, energy, and matter in terms of EM waves, where the energy of the EM wave can be expressed in terms of its mass through the spatial coordinate systems used, i.e. 1 second. Gives us a energy. The scalar energy of the field is also equivalent to the mass measurement of the field. Mass energy is equivalent through E equals mc squared, or the inertial content of a matter object is related to its energy content, as Einstein expressed in special relativity. Of course, using Tetryonic geometries, we show that the difference between mass and matter is the choice, the enforced choice of spatial coordinate systems. To measure the matter content, or the three-dimensional standing wave energies of any matter object, you have to change the coordinate system from c squared to c to the fourth. Again, the energy content remains the same, but what changes is whether you're measuring mass or matter. In the case of EM waves or photons of energy, there is no matter content. They are all two-dimensional radiant energies. In this case, they are 2 pi geometries, so they radiate in two directions from their source point, or source of creation. They radiate out at the natural velocity of energy, which is c in a vacuum. But it may be different in the case of where EM waves are propagated within water or other mediums such as quartz, etc., in which case their velocity of propagation will not be c, it will be a different velocity. Hence why within the unified field equation, the mass velocity energy geometry relationship is expressed as a velocity, not as c. in Einstein's equation it's still okay to express mass energy equivalent in terms of the speed of light, because energy propagating in a matter standing wave propagates at the natural velocity of energy, or c, and to measure the mass content of any EM wave or any energy field that's propagating per spatial system, we measure a Euclidean system of per second or per c squared, which gives us a measurement of mass. So there are specific examples where E equals mc squared is correct within mass energy matter systems. However, it's more appropriate to express it as a velocity squared rather than c squared. It just so happens to solve to be c squared in the case of EM waves and the energy released from matter. In Tetryonics, you'll see that we always express mass as n pi energies versus T pi or Tetryonic pi geometries for matter. They both have energy contents, where the mass energy contents or the energy momenta contents are expressed through the energy formulation of the unified field equation. What changes is the number of pi geometries in each system and the enforced spatial coordinate system required to measure. Of course, we can measure matter in c to the fourth or Cartesian coordinate, c cubed or Cartesian coordinate systems, but for simplicity and because we're relating to the propagation of creating a spherical coordinate system from propagation of photons specifically, we prefer to use c to the fourth, because it also gives us the ability to have a negative z component to the matter geometries under study, whereas the Cartesian coordinate system c cubed does not allow for negative z-axis components. Again, they'll both give the same result when properly calculated and with a proper understanding of the geometries involved, but without understanding these geometries, it's very easy to confuse between mass, energy, and matter, so far as their equivalence and their physical properties. Tetryonics clears this up once and for all, both in terms of mathematical formulations and the geometry that allows the specific mass-matter formulations. Of course, in the case of quantized angular momentum, or the geometry of energy itself, we can measure that per unit of time, in which case we change it from a energy equilateral and measurement of equilateral scalar energies to a measurement of mass quantized angular momentum, or Planck's constant. Again, important to note that while we can represent this as a vector rotation, or this angular momentum as a vector rotation, Tetryonics calls it quantized angular momentum to highlight the fact that it forms part of Planck's constant of quantization and that it's the equilateral geometry. The vector rotation or the angular momentum still applies within physics on the larger scales, but where you see quantized angular momentum or QAM within Tetryonics, you know it to be describing the equilateral geometry of a system. Again, you may see it occasionally within the, particularly within electrodynamics, simply expressed as alpha, in which case mass alpha is the measurement of mass or energy per second, along with the equilateral geometry or its quantized angular momentum, which of course is Planck's constant. Again, a lot of physics textbooks that have been written to date will state that you cannot express Planck's constant as purely mass quantized angular momentum. Tetryonics gives you the missing piece of this puzzle to show that it can be expressed as that, and in fact it forms the foundation for understanding alpha and the fine structure constant and the coupling constants within physics itself. Again, a separate lecture. But in all cases, as within all fields of physics, the conservation of angular momentum applies, as does the conservation of energy or mass energy within the system. What is not conservative is obviously matter, as it's simply a geometry that results from the charge interaction of mass energy fields. So mass, energy and charge is conservative, and of course time is conservative, because time is just a relativistic measurement of charge, but poorly expressed in the math. So quantized angular momentum is conserved along with mass, energy and time. So obviously mass energy can't be destroyed or created. It's a property that exists at all time and is always conserved, as is the geometry of the mass energy. Charge itself is simply the net charge, large Q, is simply the result of the addition of quantized charges or geometries. In this case, each boson has an odd number of charge quanta, as you can see here. Top one has a single quanta, so it's a net charge of 1. In the case of quantum level 2, we have 3 quanta, in which case there are 2 positive, 1 negative. Again, this will give us a net charge of positive 1. So the quantum levels themselves have W bosons, which all have a negative or a positive charge, depending on their charge arrangements within their odd numbered quanta. As these quanta join up to form scalar energies, and again they do so in specific increasing number of odd quanta, as they do that, the charge of the field increases from 1 to 2 to 3, again by how many quantum levels or bosons are within the scalar field, and this will give us properties such as voltage, etc., as in the energy within the charge geometry. Again, within all cases, the golden colouring indicates to us that it's a charge geometry. If in the case where we have positive charges added to negative charges, as you can see in the center here, we create a neutral geometry or a photon. In this case, what it's giving us is the kinetic energy of the field versus the magnetic permittivity of the field, or the electric versus M fields of the electromagnetic properties of the scalar field. Of course, in the case of charge, it is always net divergent, so as you add up the individual quanta of convergent and divergent energy momenta within the field, within any charge geometry or equilateral geometry, you will always have more divergent than you will have convergent. The outside geometry, energy momenta geometry of any equilateral charge field is always divergent. The convergent component is always internal. But again, this divergent and convergent energy momenta, when superpositioned with two fields, gives us Coulomb's law and other inverse squared laws and fields of force within electric and magnetic fields. Again, all resulting from the energy geometry. And in the case where we have positive and negative W bosons, or positive and negative energy momenta fields combining via the weak force, we have a neutralized photon of energy, and the energy flux as drawn here, or the quantized angular momentum or geometry, equilateral geometry of the photon, when expressed as a vector rotation, forms the lemskate, I believe it's pronounced, or the symbol for the infinity, where two inductors form a transformer coupling via their magnetic dipoles, and this transformer coupling allows the circulation of energy on a one-to-one basis through the photon of energy in an infinite fashion. It circulates from the positive through the magnetic field into the negative E field, from the negative E field through the magnetic coupling into the positive E field. And again, two bosons make a photon. In the case of re-normalisation within QED, or fields of force within QED, or the study of quantized energy momenta within QED, Tetryonics shows us the physical reality of the arrangement of equilateral energy momenta within any field of energy, within any scalar field of force. The force results because of the superpositioning of fields of energy, or charge fields, or chem fields. Where these fields superposition, the energy momenta of each 2D energy field interacts with the energy momenta of the other field. Again, it's a geometric relationship between the linear momenta of each scalar field, or the quanta within each scalar field, and the scalar energy itself. So we can measure it in terms of energy, mass, velocity, or even force, resulting or creating changes in linear momentum within the system, or the particles themselves that are involved. Again, whatever the force is that results, it's the result of the sum of all the energy momenta relationships within the quantized energy fields themselves. And these fields, even though we see them as positive and negative charges here, may in fact and do in fact have neutral E fields and magnetic moments, or magnetic dipoles associated with each charge or each force that's being applied. They are, as a rule, because they're two-dimensional mass energy fields, neutral to most measurements. What we can measure is the force between them, and this in fact is what's created a lot of trouble in understanding it. Faraday understood them to be fields of force. Maxwell formulated the electromagnetic and the charge characteristics mathematically of all these fields, but was unable to discern the equilateral geometries of the square numbered quanta. Now that Tetryonics has discerned this geometry, we can in fact geometrically represent all of Maxwell's equations, and in fact all of physics and science, in terms of these equilateral energy momenta and the interaction that's produced. These fields drawn here are identical in strength, but there's no reason why they couldn't be differing strengths for differing charges, for example, or the differing velocities of particles of matter in motion, in which case the force of interaction that results will differ. But in all cases they are square. They have square number of energy momenta within their equilateral geometries of their fields of force, and all the properties and the distributions of these fields of the quanta within these fields of force produce a single scalar field. Again, quantum electrodynamics for the last 50 odd years has relied on Feynman diagrams for the interactions. These are all now replaced by the equilateral mass energy or charge geometries of mass energy matter in Tetryonics to give us real representations of the physical systems, particles and forces in play between the particles themselves, so we can relinquish use of Feynman diagrams, produce and use accurate three-dimensional or accurate dimensional models of mass energy matter and forces within any system. And again, all these systems, within all these systems there are no such thing as infinities. Third law of Tetryonics, there are no infinities. In fact, we have finite quanta within squared energy fields and within charged mass matter geometries, and we use these finite numbers to calculate the forces between the particles as a result of their motion and charges, net charges, and we can renormalize the amplitudes and probabilities of all the quanta within these fields because they are finite numbers. There's no need to renormalize infinities. In fact, within Tetryonics there will be no infinities. There will all be finite numbers and quanta. As we've mentioned before, we can do measurements of three-dimensional matter using rectilinear coordinate systems or Cartesian coordinates. However, this is not the way it's normally measured when we move into relativity or relativistic measurements. We prefer to use a spherical coordinate system rather than a rectilinear or Cartesian coordinate system. But we can develop a Cartesian coordinate system, and in fact, one of the other indications that mathematics has gone off track is where the Cartesian coordinate system was used and converted into a relativistic system, spatial coordinate system, using the velocity of energy, or c, within things like Hawking radiation or entropy in a black hole. You can see clearly that c to the third is a remnant of the Cartesian coordinate system developed from Boltzmann's era of classical mechanics, translated into a relativistic measurement of the same system. But then this c to the third is a measure of entropy, is translated to Hawking radiation, for example, as a measurement of entropy within a spherical coordinate system of relativity, which uses c to the fourth. So again, Tetryonics points out that there should be an additional translation, or transformation, coordinate transformation, whether it's a Lorentz transformation or more correctly a Cartesian Lorentz transformation. No, perhaps I should word that even more carefully. It should be carefully worded to be a Lorentz transformation of Cartesian or rectilinear coordinate systems to spherical coordinate systems of relativity. So again, the current formulation of entropy in a black hole has c to the c cubed as its coordinate system. This is a rectilinear or Cartesian coordinate system, and to apply that to a spherical black hole requires a transformation of the coordinate system c cubed to c to the fourth, and this is done via a Lorentz transformation. Currently it hasn't been done, and entropy in a black hole is still expressed in a Cartesian coordinate system. Obviously we can develop polar coordinate systems, as we have done for equilateral energy or superposition fields of force, or even particles of matter themselves. We can view them in a polar arrangement, and we can see the energy momenta of all these particles and fields of force and scalar energies, mass energies, and these form all the familiar constants and all the familiar physical properties of mass, energy, matter. They're all just different ways of measuring the same equilateral energy momenta of any system, any physical system. Of course, in the case of relativity using spherical coordinate systems, the polar or curvilinear coordinate system developed by Einstein through Riemannian curvatures is a polar system. So it is c to the fourth, not c to the third, as we've just previously discussed. As we also mentioned, to convert between the Cartesian coordinate systems c to the c cubed to the spherical coordinate systems involves a coordinate transformation, and this is at the heart of relativity, although, as we just mentioned, not all formulations of rectilinear systems have been converted to polar or Riemannian curvatures of energy density, and this is something that great care has to be taken. And again, it's Tetryonic geometry or equilateral energy momenta that highlights that the mathematics as a language has failed without the grammar of the geometry. The as we just said, the c squared or cubic Cartesian coordinate systems are completely different to the spherical Riemannian curvatures or coordinate systems. In both cases, the energy geometry remains the same. It's an equilateral energy geometry, whether it's scalar measurements or the quanta within those scalar fields of force. But what changes obviously is the mathematics that results when you map equilateral geometries within either Cartesian or Riemannian curved geometries or coordinate systems. And again, Tetryonics clearly shows the quick way to identify which coordinate systems in use is whether you have c cubed, c squared, or c to the fourth within your mathematical formulations for the mass, energy, matter, or the energy densities of any physical system. Again, relativity lumps mass, energy, matter into a single stress energy tensor and describes the entire system in terms of gradients of energy density within that system. Tetryonics obviously goes to much finer detail in that we use equilateral geometries of mass, energy, and through the interaction of charge with the mass, energy geometries, we create three-dimensional matter geometries, and we can map these either in rectilinear or trilinear with rectilinear or trilinear spatial coordinates within either Cartesian or Riemannian spherical geometries. Again, in each case we quickly know which is being calculated for and which coordinate system is being measured or being used to measure the system, purely by definitions of n pi for mass, energy, per c squared for Euclidean space, versus 4 pi or t pi geometries for matter within c to the fourth Riemannian curvature or spherical geometries. The only exemption to this is where we do relativistic general relativity, where everything is measured in c to the fourth. Again, a reason why c to the third is not used, because where you have superpositioned mass, energy, which is energy per c squared, where they superposition, they create a coordinate system of c to the fourth, which is equivalent to a Riemannian curvature. This then allows us to measure mass and superpositioned mass, energy, or force within this spherical coordinate system of c to the fourth that's used for matter, three-dimensional geometries. This rationalizes the coordinate systems, whereas if you used Cartesian coordinate systems of c cubed, you get irrational, or you have to rationalize the coordinate systems through a transformation in order to map both mass, energy, momenta or force to the mass energies of matter. Again, more detail will be given on this within further discussions on general relativity and specific. You can see it drawn here as summary for the spatial coordinate systems or spatial geometries. One's determined by the other. If you're just measuring a force, obviously it's a linear force, so we just use vectors to describe that, and it's usually denoted by c, velocity per c, etc., or velocity as a measurement of meters per second, acceleration, again just a scalar measurement of the same. In the case of mass, energy, we have biradial propagation of energy, which results in the necessity to translate our spatial coordinate system to a c squared coordinate system, where we're measuring, which will generate a mass, energy equivalence through the c squared spatial coordinate system. We can develop a Cartesian coordinate system in classical mechanics using c cubed, where the energy propagates in x, y, or z directions to create a cubic measurement or a rectilinear coordinate system. Or we can use c to the fourth for Riemannian curvature or spherical spatial coordinate systems. And in fact, this is the preferred coordinate system, because mass, energy is a measurement of the propagation of photons, for example, or bosons, and they're measured per c squared, and where they generate force through their superpositioning, the c squared geometries, or the superposition c squared mass, energy geometries, create a c to the fourth geometry, which is perfect for showing mass, energy, matter and force within the stress energy tensor of relativity. So all of quantum electrodynamics can now be re-expressed in terms of equilateral mass energies, and the mathematics of all of the electrodynamics of matter in motion and the fields of force between the particles can also be shown to be the result of equilateral geometries of energy rather than a result of the mathematics. So in fact it's the geometry that forms the foundation for all of the mathematics for physics, quantum mechanics, electrodynamics and relativity. At this stage we'll finish this discussion. There will be a further lecture on applying geometries to mathematics, but this is sufficient for an introduction into special relativity, and in particular how the energy content of matter relates to its inertial content or its inertial mass, and how the equilateral energy momenta or mass energies of any scalar field produce all the properties of special relativity, i.e. Lorentz transformations, Lorentz correction factor, and the fields of force, along with electrostatic fields of point particles without motion versus the magnetic moments of charged particles in motion. Thanks for your time on this one. I hope it's given you a good foundation, and if you have any questions, feel free to email me and I'll answer them directly.